Deep beneath the waves off the coast of Oregon lies a hidden world of volcanic activity. It's a world that few ever witness, but it's a world that holds clues to the powerful forces shaping our planet. At the heart of this world is Axial Seamount, an underwater volcano full of mystery and wonder. Axial Seamount is a giant among volcanoes. It rises over 3,000 feet from the ocean floor, its peak still submerged over a mile below the surface. This underwater giant is a shield volcano, its gently sloping sides built up over millennia by countless eruptions. Though hidden from our view, Axial Seamount is far from dormant. In fact, it is the most active volcano in the Northeast Pacific Ocean. And right now it's showing all the signs of an imminent eruption. Scientists have been closely monitoring Axial Seamount for decades. They use a variety of instruments to keep tabs on its every move. Recently, these instruments have picked up a dramatic increase in activity. The seafloor near the volcano is rumbling with thousands of tiny earthquakes every day. This seismic activity is a clear indication that magma is rising from deep within the earth, making its way towards the surface. The volcano itself is swelling like a balloon about to burst. These signs are all too familiar to the scientists who study Axial Seamount. They've seen it all before. In 2011 and 2015, Axial Seamount erupted, spewing forth lava and creating new seafloor. Now, all signs point to another eruption, perhaps even more powerful than the last. You might be thinking, an underwater volcano erupting hundreds of miles offshore, why should I care? It's a fair question. After all, Axial Seamount is far from any major population centers. Its eruptions are unlikely to cause any direct damage. But the truth is, Axial Seamount has a lot to teach us. By studying this underwater giant, scientists can learn more about how volcanoes work. They can study the processes that drive eruptions, and the impacts those eruptions have on the surrounding environment. This knowledge is essential for understanding the risks posed by volcanoes all over the world, both on land and beneath the sea. Axial Seamount is a natural laboratory, providing a unique window into the inner workings of our planet. Axial Seamount is no stranger to eruptions. In fact, it has erupted 3 times in recent history, in 1998, 2011, and 2015. Each of these eruptions has provided scientists with valuable data about the volcano's behavior. The 1998 eruption was the first to be detected at Axial Seamount. It was a relatively small eruption, but it confirmed what scientists had long suspected. Axial Seamount was an active volcano. The 2011 eruption was much larger, producing a massive lava flow that covered an area equivalent to the size of Manhattan. The 2015 eruption, while not as large as the 2011 event, was notable for its duration. Lava flowed from the volcano for several months, providing scientists with an unprecedented opportunity to study the eruption process in detail. Section 5. A peek inside the Earth. One of the most intriguing aspects of Axial Seamount is its connection to the Juan de Fuca Ridge. This underwater mountain range is a boundary between 2 tectonic plates, the Juan de Fuca Plate and the Pacific Plate. As these plates slowly move apart, magma rises from the Earth's mantle to fill the gap, creating new seafloor. Axial Seamount sits directly atop the Juan de Fuca Ridge, providing scientists with a unique opportunity to study the interplay between plate tectonics and volcanic activity. By studying Axial Seamount, scientists can gain a better understanding of how the Earth's crust is formed and how magma moves from the mantle to the surface. This knowledge is essential for understanding the fundamental processes that shape our planet. Section 6. Monitoring a submerged giant. Monitoring an underwater volcano presents unique challenges. Scientists can't simply climb to the summit of Axial Seamount and peer into its crater. Instead, they rely on a suite of sophisticated instruments to keep tabs on the volcano's activity. One of the most important tools in their arsenal is the Ocean Observatories Initiative, or OOI. This network of underwater sensors provides real-time data on a variety of oceanographic parameters including seismic activity, water temperature, and water chemistry. The OOI allows scientists to keep a constant watch on Axial Seamount, even when research vessels are not present. In addition to the OOI, scientists also use remotely operated vehicles, or ROVs, to explore the seafloor around Axial Seamount. These underwater robots are equipped with cameras, sensors, and sampling devices, allowing scientists to collect data and samples that would be impossible to obtain any other way. Section 7. The importance of axial seamount. Axial seamount may seem like a remote and insignificant feature, hidden beneath thousands of feet of water, but in reality, this underwater volcano plays a crucial role in our understanding of the planet. By studying axial seamount, scientists can learn more about the processes that drive volcanic eruptions, the impacts of those eruptions on the surrounding environment, and the fundamental forces that shape our planet. This knowledge is essential for a variety of applications, from assessing the risks posed by volcanoes on land to understanding the role of hydrothermal vents in supporting life in the deep ocean. Axial seamount is a natural laboratory providing scientists with a unique opportunity to study the Earth's inner workings in a way that would be impossible anywhere else. Section 8. Unlocking the secrets of volcanic eruptions. One of the most pressing questions facing volcanologists is how to predict when and where eruptions will occur. Volcanoes are complex systems, and their behavior can be difficult to predict. But by studying axial seamount, scientists are gaining new insights into the factors that trigger eruptions. For example, scientists have observed that the seafloor around axial seamount inflates and deflates in the years leading up to an eruption. This inflation is caused by the buildup of magma beneath the surface. By monitoring these changes in seafloor elevation, scientists can get a better sense of when an eruption might be imminent. This information is critical for mitigating the risks posed by volcanoes, both on land and beneath the sea. Section 9. Axial seamount, a window into our planet's fury. Axial seamount is a powerful reminder that our planet is a dynamic and ever-changing place. Beneath the waves, hidden from our view, forces beyond our control are constantly reshaping the Earth's surface. By studying axial seamount and other underwater volcanoes, we can gain a deeper appreciation for the power of these forces and the importance of understanding how they work. The knowledge we gain from these studies can help us to better protect ourselves from the risks posed by volcanoes and other natural hazards. Axial seamount is a window into our planet's fury, a glimpse into the awesome power that lies hidden beneath the waves.